Hello students and welcome to this video lesson. Today we're going to do algebraic proofs. So our learning objective is I can write an algebraic proof using theorems and deductive reasonings to find a solution. So by the end of the lesson you should be able to do this success criteria. You will understand what a two-column proof is and you'll be able to do the algebra involved. So like I said, it's an algebraic proof. So let's do a little review of Alg 1 here. Hopefully when you see this equation, you think to yourself, yep, I can solve for x. So go ahead and pause the video, take a moment, and see if you can find the value of x. Okay, ideally you did the following process. You added 13 to both sides, you divided by 2, and you got x equals 4. So what I'm going to do is I'm going to take this problem and put it in the format of a two-column proof. So in a two-column proof, you have two columns. The first column is called the statements. The statements is the actual math that you do. The reasons are the reasoning behind it. This is the thought process that you want to explain to the person who's looking at your proof. So we'll just start with the statements because that's usually the easiest part to look at first. The statements are just what did I do? Well, what I did first is I added 13 to both sides. You'll notice I didn't show my step between here. I didn't show the plus 13, the plus 13. This is one of those rare instances in math where you don't necessarily have to show all of your work. After that, I said I divided by 2, and I got my answer, x equals 4. So I'm not showing this step in between, and the reason why is because I'm taking care of that in my reasons. So let's start with reason 1. Reason 1 is just the problem. They gave us the problem. Well, why? Because they told me to do it. So the reason always is given. The first reason in any proof, algebraic or geometric. Okay, so if we want to look at the second reason, most people look at the second statement and look at the second reason and say, well, those have to be connected. They are, but you also have to remember it's connected to the previous statement or previous statements, depending on what's up there. So you want to think to yourself, what did I do to statement 1 to get to statement 2? What changed from here to here? Well, we said it, we added 13 to both sides. So I'm just going to call that addition. So like I said, I didn't show the adding 13 because I explained it over here. So if I want to look at reason 3 is going to be related to statement 2. How do I go from statement 2 to statement 3? Well, I divided both sides by 2. So I'll just call that division. These things right here, this addition and division, these are called algebraic properties. So that brings us to our next slide. In the algebraic properties, there's a bunch of them. So we're going to put these into our guided notes packets so we have it for reference. So I'm just starting with the caveat if A equals B. So in other words, if something is equal to something else. Okay, so we're starting with an equation. Well, you know the golden rule of math is whatever you do to one side, you have to do to the other. And so that's what these 4 things say. If I have an equation, I must add something to both sides to still make it true. So if I add C to both sides, it's still equal. Same thing for subtraction. I can subtract the same thing for both sides, and it's still an equation. If A equals B, then A minus C equals B minus C. Okay. Multiplication, I'll go through this quickly, is just multiplying both sides by the same thing. And division is dividing both sides by the same thing. You'll notice I wrote C can't equal 0 simply because you can't divide by 0. So we use the division and the addition back in the previous example. They all disappeared here. Let me do that again. So we added 13 to both sides, so we did the addition property. We divided both sides by 2, so we got the division property. So I probably should have written addition property of equality and division property of equality here. Those are kind of lengthy. So for now, I'm going to just let you get by with saying division property or subtraction property. You don't have to write the equality part. Okay, these are the other algebraic properties that are on your guided notes, and these are kind of weird ones. You'll understand them better when we get to our geometric proofs. So just bear with me and put them in your notes for now. The reflexive property says that anything equals itself. Pretty self-explanatory, I think, right? I like to remember this one because I figure I look in the mirror and I see my reflection and I see myself back. It's exactly me. Nothing changes when you look in a mirror. So something equals itself. Always true. The symmetric property, I think of symmetry. You know, like when you fold a piece of paper, something on one side is the same as the other, but it's a mirrored image. So it works the same in math. If you have an equation, say, you know, 2 equals 1 plus 1. Well, if I switch those around, I go 1 plus 1 equals 2. Same thing. It doesn't matter if it's on the left or the right side of the equation. It's still true. So the symmetric property says you can flip it around, no big deal. The transitive property, I think of this one as a train. So if I have the front of the train is connected to the middle, and the middle of the train is connected to the end, well then obviously everything is connected, so the front is in fact connected to the end. Okay. This could make more sense if I talk about substitution. Substitution property you've done before in Algebra 1. That's when you can replace something with something of equal value. So what I basically did in the transitive property is I replaced B with C because B equals C. So I substituted it. So the transitive property is a very specific case where substitution is just a case-by-case basis that you just replaced one thing, whereas this is replacing an entire side of an equation. And finally, we get to the distributive property, which I'm sure you've done before. If you have a number outside parentheses, you have to distribute it in. Okay, so now if you look at your guided notes, we're actually going to skip this next portion. This is what we'll do on the next day when we do algebraic proofs. So skip this guy, skip this guy. You know what? We're going to go right to the success criteria. So ideally, you understand what a two-column proof is, and you would be able to actually do the math, that's the statement side, and explain why you did it using those algebraic properties. So pause the video here for a moment and see if you can fill this out, and I will give you the answers in just a moment. Okay, we'll start with the statements. First off, what I did is I distributed because I didn't want to have those parentheses anymore. So I distributed the 2 in, and I got this. Then I wanted to combine the -10 and the -4. So I got -14 instead. Then I wanted to add 14 to both sides, so I got 6x equals 18. And finally, I divided both sides by 6, and I got 3. So let me just explain that all over again when I go to the reasons column here. Well, reason 1 always is given because they gave us, this is the problem, go ahead and start it. Next, what I did from statement 1 to statement 2 is I distributed. So again, I said you can go take a shortcut and just write distributive property. You don't have to write distributive property of equality. Okay. Now, the next step is kind of weird, but what I actually did is not really an algebraic property at all. I just kind of simplified the equation. So there's 2 ways I might mention this. I would either say simplify or combine like terms, because both of these are constants, so I combined them. So from 2 to 3, I simplified or combined like terms. So it's not a property per se, but it's something that you're allowed to do in math. Okay, next I added 14 to both sides, so I used the addition property. And finally I divided, so I used the division property. Alright, well that's your video for today. Hopefully that made sense. And tomorrow when you come to class, we'll be doing some book work. And yeah, have a great rest of your night.